Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 10, Isosceles Triangles, Exercise 10A. This exercise is pretty easy. Now, let's start with question 1. This is the diagram given. And the data is provided. We have to prove that BC is equal to CD. So what we'll do here is, first of all, it's given that AB is equal to AC. It's an isosceles triangle. Now these two angles are given, so we can say that angle BDC is equal to 48 plus 18, since it's an exterior angle of triangle CDA. So 48 plus 18, so this becomes 66. Next, since it's an isosceles triangle ABC, let's assume this is X and this whole angle is also X. But by angle sum property, 48 plus X will be 180. So we get the value of X as 66. So now that we have proved these two angles equal, hence it follows that BC is equal to DC, isosceles triangle property. Next, question 3. This is the question. Let's start with Roman number 1, where we have to find angle EDC. Now, the moment I saw these parallel lines, I knew that this angle is equal to this angle, alternate angles. So if I can find this angle, then we'll be able to find this as well. What's given is this is 128, and this is an exterior angle for triangle ABC, and it's an isosceles triangle. So let's assume this whole angle is X and this whole angle is also X. So by angle sum property, I can find the value of this X, because actually instead of angle sum property, it will be simpler to just use exterior angle property, that is 128 is equal to X plus X. If you want to do a longer method, that is first find this angle by linear pair and then use angle sum property, but that's longer, so I'm not going to use that. So 128 is equal to X plus X, exterior angle property, so X comes out to be 64, and even this one, by the way, the whole angle BCE. But I'm interested in this angle here. This angle is 64. Now it's always better to use 3-letter naming for all angles, which avoids all confusion. Only if something is very clear. For example, here I've written in triangle ABC, angle B is equal to angle C. So when I have mentioned the name of the triangle, then it's very clear that when I see angle C, I mean the entire angle C. Otherwise, it's always safer to write the 3-letter naming for angles. So here, once I got this, the 64, now it is given that triangle CBD is an isosceles triangle. So what follows is that even this angle is 64. And so by angle sum property in triangle DBC, if this is 64 and this is 64, I can calculate this small angle DCB, which will be 52, and by alternate angles property, even this is 52. So that's how I get Roman number 1 answer. Now Roman number 2 asks for angle DCE. Well, this total angle X was what, 64? We found that. Subtract 52 from that, we get this angle as 12. So I'll be sending you pics of all these solutions, but if you wish, you can pause it and solve as well. Now question 5, this is the data given. So let's start solving. We have to prove that angle BOC, that is this angle, is equal to angle ACD, that is this angle. That's what we have to prove. Now it's given that it's an isosceles triangle. That means this side is equal to this side. So this whole angle B is equal to this whole angle C. Let's assume that it's 2x and 2x. And since these smaller angles are half of the big angle as given in the question, so now we can say that this is x, x, and even this is x and x. So all these four angles are equal as per the given data. Now in triangle OBC, if you use angle sum property, angle O turns out to be 180 minus 2x. And angle ACD is forming a linear pair with angle ACB. So it will be 180 minus 2x as well. So you see, this angle is equal to this angle indeed. Now question 7 has no diagram, but this is the given data. Drawing the correct diagram is so crucial, otherwise the whole sum will be wrong. So what's given is that CA is equal to CB, it's an isosceles triangle. This angle is 55 and CD bisects AB. That means D is the midpoint. It bisects AB. It's not an angle bisector. It just bisects the side AB. D is a midpoint, means this is equal to this. And we've been asked to find, first of all, this angle and also this one. So I'm going to find this angle first. Hence I wrote Roman number 2 first. Prove these two triangles congruent. Pause and think how. Okay, I hope you got SSS test here. This side is equal to this side given, this side is equal to this side given, and CD is equal to CD common. So SSS test, they are congruent. So if this is 55, this is also 55, because the angles are equal by CPCT, corresponding parts of congruent triangles are always equal. You've studied that in congruency chapter. And now Roman number 1. Well, I can say that this angle is equal to this angle also by CPCT. So let's assume they are x and x respectively. Now in the big triangle CAB, this angle A plus C plus B is totally 180, angle sum property. That means 55 plus 55 plus 2x is 180. So that way we can get the value of x as 35 degrees. Now the ninth sum. This is the question, this is the data given. We have to find the values of x and y. The moment I saw this, I knew it's a simultaneous equation sum. What's given is that this angle is equal to this angle, because that's what is given in the question. Also, they have said that this is a perpendicular here, so 90-90. So these two triangles are congruent by which test? Pause and think about it. Well, I hope you got ASA test, because angle equal, common side, and 90-90, ASA test. So if these two triangles are congruent, that means side is equal to side by CPCT, and also this side is equal to this side by CPCT. So 3x plus 1 is equal to 5y minus 2 is one equation, and x plus 1 is equal to y plus 2 is the second equation. Rearrange the terms to get it in standard form. And once you get the two equations, you know how to solve simultaneously. I have done the elimination method to get x and then substitute it to get y. So here's the solution. There is no isosceles triangle property used in this sum. Actually, this sum belongs to congruency chapter. Next, 11th sum. This is the question and the data given. Now we have to find angle CAB out here. This entire angle has to be found out. So it seems that we'll have to find this small angle first and then this angle later, and then we'll have to add them up. So let's do it. First of all, in this triangle CAD, which is an isosceles triangle as given, if this is 58, let's assume this is x and this is x. So by angle sum property, we can get the value of x, which turns out to be 61 degree. And even this is 61, by the way. This is an exterior angle of triangle ADB. You see, if we extend any side of a triangle, then that angle which forms linear pair with the interior angle is called the exterior angle. And the property of an exterior angle is that it is equal to the sum of the remote interior angles. That means angle ADC is equal to angle DAB plus angle DBA. And interestingly, in triangle ADB, which is an isosceles triangle, this angle is equal to this angle, which is y. Why are they equal to y? Because of isosceles triangle property. So 61 is equal to y plus y, exterior angle property. So we get y's value as 30.5. So in the end, the total angle is 91.5 degrees. Now 13th sum, again diagram is not given, but it's a very easy sum. It's an isosceles triangle and the ratio of angles A and B have been given as 8:5. So whenever ratio is given, we assume the common proportion to be x. So we'll assume A to be 8x and B as 5x. And it's an isosceles triangle, so this angle is equal to this angle by isosceles triangle property. So even this is 5x. And then angle sum property is 180, get the value of x, substitute and get the value of 8x, which is 80 degrees, as you can see in the solution. Next, 15th sum. This is the question. Again, diagram is not given, so be very careful while drawing the diagram. Try to draw the diagrams without looking at the solution. Whenever I show you a question, you should pause the video, read the question in your textbook, and try to draw it on your own. And then check it by seeing the video ahead. That's the way to learn geometry and train your brain. If we see the solution first, we feel that it's easy and we feel we know it. But then in exam we get stuck. So follow the procedure I'm teaching you to. Now in the 15th sum, what's given is that it's a right angle triangle at angle B, and also this angle is equal to this angle. So triangle PBC is an isosceles triangle. And we've been asked to prove that PA is equal to PB. So it seems that we'll have to prove this angle equal to this angle, so that by isosceles triangle property, PA will become equal to PB. But how do I prove this angle equal to this angle? First of all, it's given that this angle is equal to this angle, so that will be x and x. And this angle ABC entirely is 90. That means this angle ABP will become 90 minus x. Also, if we use angle sum property in triangle ABC, and this is x and this is entirely 90, so this angle becomes 90 minus x as well after calculation. This proves that these two angles are equal, and so the two sides are equal by angle sum by isosceles triangle property, and here's a solution for that. In the 17th question, again diagram is not given, so we'll have to draw it. Note that DB is equal to DC is equal to CA, and this angle is 28. We've been asked to find ACD, that is this angle. So step by step, from here we'll have to reach here. So let's start. This is 28, so by isosceles triangle property, even this will be 28. Now this angle ADC is an exterior angle for triangle DBC. That means this angle will be equal to angle DBC and angle DCB combined. That means this is equal to 28 plus 28. That's exterior angle property, which becomes 56. Yes, we could have done angle sum property and then linear pair, but exterior angle property is shorter. And please use 3 letters while naming angles as much as possible. Now, if this is 56, then in triangle ADC, even this will be 56 by isosceles triangle property. So by angle sum property, this is what is left, and the sum is 180. So how much will this be? That's right, 68. Now finally the 19th sum, it's a proving sum, but the names of the triangles and the angles etc. have been given. So we don't have to write the given. We can directly start proving it. And here OR is mentioned, which means Roman number 1 and Roman number 2 are basically the same question. So we just have to solve it once. What is given is that in this triangle, AD is the angle bisector of this angle A, as well as it is perpendicular to side BC. Perpendicular, not perpendicular bisector. It's just an altitude. D is not the midpoint in this sum. And we have to prove that this triangle ABC is isosceles. That is, we have to prove that AB is equal to AC, which I guess will be by CPCT. So let's try to prove these two triangles congruent. Can you guess which test will apply here? ASA test. So this angle is equal to this angle given. This angle is equal to this angle, both are 90 given. And this side is equal to this side, same side, common side. So ASA test, congruent triangles proved. And so this side is equal to this side by CPCT. Hence, it's an isosceles triangle. Don't forget to write the final statement.